Hello students, welcome. Previously, lesson 21, from 4 to big 4, we were dealing with the third aim of calculating Faraday's first law of electrolysis, which was determining the volume of gas liberated at the electrodes. So today in lesson 22, we are going to proceed to the fourth aim, which is determining the relative atomic mass of elements. So the formula used when we are calculating R.A.M, the formula that we are going to use is M multiplied by N multiplied by F divided by Q, where Q is the quantity of electricity passed, and we said Q can be obtained by using the formula IT, where I is current measured in amperes and T is time, and we said time must be in seconds. So M is mass in grams deposited, N is the number of electron gain or loss, in other words, number of Faradays, or the value on the charge of the metal. Then F is Faraday, and it is given by 96,500 coulombs, and R.A.M is relative atomic mass of element. Examples. Let's start with example number 1. We are told when a current of 1.56 ampere was passed through an electrolytic cell for an hour. 2.2697 grams of a monovalent metal was deposited. Then we are asked to calculate the relative atomic mass of the metal. In bracket, we are given Faraday constant, which is equal to 96,500 coulombs. So the formula that we are going to use when we are calculating R.A.M is equal to M times N times F divided by Q, where M is mass. So the mass here is 2.2697 multiplied by N, which is the number of Faradays. Here, for us to know the number of Faradays, we are given the valence of the metal. We are told monovalent metal. So that means if the valence is 1, that means the charge there is balance 1. So that means the number of Faraday will be 1. Multiplied by F. F is Faraday constant, which is equal to 96,500 coulombs, divided by Q. Remember, we said Q is obtained by using the formula IT. I is current, which is measured in amperes, so 1.56 multiplied by time. Time here is an hour, that's 1 hour, but we have to convert it into seconds. So we multiply it by 60, again by another 60 to convert it into seconds. When we put all this in the calculator, what we are going to get is 39. So that means the R.A.M is 39. Remember, R.A.M has no unit. We are going to leave our answer like that. Example number 2. We are told when a current of 2.09 ampere was passed through a solution containing T ions of metal T for 20 minutes. The mass at the cathode increased by 0.52 gram. Then we are asked to determine the relative atomic mass of T. We are having Faraday constant, which is equal to 96,500 coulombs. So we are going to use the same formula. R.A.M is equal to M times N times F divided by Q. M is the mass. The mass here has been increased by 0.52 multiplied by N. N is the number of Faraday. Check the charge, the value on the charge is 2. That's the number of Faradays multiplied by F. F is Faraday, which is given in the bracket 96,500 coulombs, divided by Q. Q is the quantity of electricity passed, and it is equal to current multiplied by time. So the current is 2.09 multiplied by 20 minutes, but we have to convert the time into seconds by multiplying by 60. When we put all this in the calculator, we are going to get 40.02 as our R.A.M. Example 3. We are told when a current of 1.5 amperes was passed through a cell containing M3 plus ion of metal M for 14 minutes and 55 seconds. The mass at the cathode increased by 0.26 gram. We are told determine the relative atomic mass of metal N. In bracket, we are given F or 1F, which is equal to 96,500 coulombs. So the formula is R.A.M is given by M times N times F divided by Q. So M is 0.26, that's the mass, multiplied by N. N is the number of Faradays, in other words, the number of electrons gain or loss, or the value on the charge of the metal. So the value on the charge, that's 3. So our N is 3, multiplied by F. F is the Faraday, that's 96,500 coulombs, divided by. So Q is quantity of electricity burst, and it's equal to I times T. I is current, which is measured in amperes, that's 1.5, multiplied by time. The time here is 14 minutes and 55 seconds. So you have to take 14, we multiply it by 6 to convert it to seconds, and we add 55 seconds. So when we put all this in the calculator, we are going to get 56.067 as our R.A.M. Remember, R.A.M has no unit. Next, we are going to have extended questions. We have only one question. Kindly try to answer that question. Thank you for watching.